Skyscrapers used to be all about reaching for the clouds and looking impressive, but after a tragic day in 2001, everything changed, including the way we build skyscrapers. Now, safety is just as important as how tall and magnificent they look. So, let's find out how 9/11 changed skyscraper design forever. The late 19th and early 20th centuries saw the rise of skyscrapers primarily in the United States. These structures symbolized technological progress and economic power, mainly in cities like New York and Chicago. The development of steel frame construction and the invention of the elevator were pivotal in enabling the construction of taller buildings. Height was often pursued for its symbolic value, reflecting ambition, innovation, and economic success. Iconic structures like the Empire State Building and the Chrysler Building epitomized this era. Aesthetics played a significant role, with architects focusing on creating visually impressive and memorable structures. Art Deco and international styles were prominent, characterized by decorative elements and clean, functional lines, respectively. Design strategies aimed at maximizing usable floor space, often through open floor plans and minimal interior columns. This approach catered to commercial needs, providing flexible spaces for offices and other uses. Large windows and high floors offered panoramic city views, which were considered a major selling point for tenants and businesses. The primary safety concern addressed was fire. Building codes mandated fire-resistant materials, sprinkler systems, and fire escapes to protect occupants. Beyond fire safety, there was minimal emphasis on security threats such as terrorism or structural sabotage. The design focus was more on preventing accidental rather than intentional harm. The use of steel frames allowed buildings to reach unprecedented heights while maintaining structural integrity. This innovation was a cornerstone of skyscraper construction. Engineers designed skyscrapers to withstand natural forces, particularly wind. Techniques like tapering at the top and using setbacks helped mitigate wind stress. The integration of advanced elevator systems was crucial for the functionality of tall buildings, allowing quick and efficient vertical transportation. Centralized heating, ventilation, and air conditioning, or HVAC systems, were developed to ensure comfort throughout the entire building. Skyscrapers were often part of larger urban development plans aimed at maximizing land use in densely populated areas. They provided significant commercial space in city centers, driving economic growth. Zoning regulations influenced skyscraper design, dictating aspects like building height, setbacks, and floor area ratios to ensure harmonious urban development. On September 11, 2001, the World Trade Center became the target of a coordinated terrorist attack. 19 terrorists associated with the extremist group Al-Qaeda hijacked 4 commercial airplanes. 2 of these airplanes, American Airlines Flight 11 and United Airlines Flight 175, were deliberately crashed into the north and south towers of the World Trade Center, respectively. Flight 11 struck the north tower between the 93rd and 99th floors. The impact caused immediate destruction and a large fire, compromising the building's structural integrity. Flight 175 hit the south tower between the 77th and 85th floors, similarly causing extensive damage and fires. The intense fires fueled by the plane's jet fuel weakened the steel structure of both towers. Despite the building's robust design, they were not engineered to withstand the extreme conditions created by such impacts and the subsequent fires. Post 9/11, the design and construction of skyscrapers underwent significant adaptations to enhance security and resilience against potential terrorist attacks. Skyscrapers began incorporating stronger materials and innovative engineering techniques to withstand extreme forces, such as those generated by explosions or impacts. Steel and concrete were reinforced, and buildings were designed to better distribute loads and resist progressive collapse. Special attention was given to the strengthening of construction materials to ensure harsh conditions. High-strength concrete and ultra-high-performance fiber-reinforced concrete, or UHPFRC, emerged as key solutions. Fire safety systems were upgraded to include more robust fire-resistant materials, advanced sprinkler systems, and improved smoke control mechanisms. Additionally, buildings implemented redundant fire evacuation routes and enhanced communication systems to facilitate timely evacuation in case of emergencies. Security became a paramount concern, leading to the integration of advanced security technologies such as blast-resistant facades, perimeter barriers, access controls, and surveillance systems. These measures were aimed at deterring potential attacks and minimizing the impact of security breaches. Skyscrapers have adopted comprehensive emergency preparedness plans, including regular drills and training programs for occupants and emergency responders. Advanced monitoring systems, including CCTV cameras and sensors, have been installed to monitor building perimeters and detect any suspicious activities. Additionally, buildings have implemented stringent access control measures to regulate entry and monitor the movement of individuals within the premises. Buildings are designed with features to mitigate the impact of explosive blasts, such as reinforced concrete cores, blast-resistant windows, and structural hardening measures. These features aim to minimize casualties and structural damage in the event of a terrorist attack involving explosives. Skyscraper developers and owners collaborate closely with government agencies and security experts to assess and address potential vulnerabilities. This partnership facilitates the exchange of information, best practices, and regulatory guidance to enhance the security posture of high-rise buildings. The adoption of post-9/11 adaptations in skyscraper design also has economic implications, as incorporating advanced safety features and technologies often incurs additional cost. Architects and developers must weigh the cost of implementing these measures against the benefits of enhanced safety and security. Moreover, these changes cause cultural and psychological shifts in urban landscapes. Skyscrapers have become symbols not only of architectural achievement, but also of resilience and collective memory, reflecting society's response to traumatic events. Current skyscraper designs continue to evolve, incorporating many new aspects. Sustainability is a major focus in modern skyscraper design. Buildings are incorporating energy-efficient systems, green roofs, solar panels, and advanced insulation materials to reduce energy consumption and minimize environmental impact. Additionally, architects are designing skyscrapers with features like natural ventilation and daylighting to enhance the occupant comfort and well-being while reducing reliance on artificial lighting and HVAC systems. Many new skyscrapers are designed as mixed-use developments, combining commercial, residential, retail, and recreational spaces with a single structure. This trend promotes urban density, reduces commuting times, and creates vibrant 24/7 communities where people can live, work, and socialize nearby. Architects are pushing the boundaries of creativity with striking and iconic designs that redefine skylines. These designs often feature unique shapes, innovative facades, and structural marvels that capture attention and become landmarks in their own right. Skyscrapers are increasingly incorporating smart building technologies to enhance efficiency, safety, and occupant experience. These technologies include IoT or Internet of Things, sensors for monitoring and controlling building systems, predictive maintenance algorithms, automated lighting, and climate control, as well as advanced security and access control systems. Architects are integrating biophilic design principles to reconnect occupants with nature and improve their health and well-being. This includes incorporating elements like indoor gardens, green walls, natural materials, and access to outdoor spaces, which have been shown to reduce stress, increase productivity, and enhance overall satisfaction. As cities continue to grow and space becomes more limited, skyscrapers will play a crucial role in vertical urbanism. Future designs may even see taller and more efficient buildings that accommodate a mix of uses within a single structure. With advancements in materials science, robotics, and AI, future skyscrapers may exhibit adaptive and responsive architectural features. Buildings could dynamically adjust their shapes, configurations, and environmental conditions in response to their changing weather patterns, occupancy levels, or user preferences. This flexibility would optimize energy efficiency, comfort, and functionality in real time. With the increasing frequency of natural disasters and climate-related challenges, future skyscrapers will prioritize resilience and disaster proofing. Buildings may incorporate advanced structural systems, modular designs, and innovative materials capable of withstanding extreme events such as earthquakes, hurricanes, and floods. Resilient skyscrapers will serve as safe havens for inhabitants and critical infrastructure during emergencies. As skyscrapers reach greater heights, efficient vertical transportation systems will become essential. Future designs may feature next-generation elevators and vertical transportation technologies capable of moving people and goods swiftly and safely over long distances. This could include advancements in maglev elevators, skypods, and multi-cabin systems that optimize space and reduce waiting times. So, even though skyscrapers are still reaching for the sky, builders are doing it with a lot more safety features. It's a reminder that even in the face of tragedy, we can learn and improve the way we build things to keep people safe. What other things do you think have changed since 9/11? Share your thoughts in the comments below. And subscribe and ring that bell for more explorations about how the world around us works.